Hello, Spring 2017 programming team for SoluBuddy. How are you doing? This is my second video installment about the program and the modifications that are needed, or the currently sort of where we are with the program and what needs to be changed next. Okay, so in the second video installment, I'm going to first review the calculations associated with adding a solute by volume. I think we have this one pretty much straightened out in the program, but it never hurts to go back over some of the basic things. So we're going to work through an example, adding a solute, methanol, which is a pure liquid, to a solution. Okay, and we're going to transfer it by volume. As you know, we could transfer it by mass or by volume for gravimetric or volumetric transfers, respectively. We're going to calculate what volume we need to make that solution. Okay, so our calculation of the volume of methanol pure solution that we need to add goes this way. We have to multiply the volume of the solution by the concentration, the final solution that we're preparing. And doing so, multiplying the volume by the molarity is always going to tell us the number of moles of the solute that are present there. Simple calculation, but we're going to transfer this by volume, so we need to go on now. So far we've got the moles of the solute in that solution, but we want to know what's the mass that's needed. So multiply the number of moles by the molecular weight, but we need to go another step and multiply that mass of the solute by the density of that solute in its pure liquid form. Let's multiply those together. Let's do a specific example. I'm going to jump over to the website. I'm going to enter in some numbers here. Volume. I'm going to make a 1 liter solution, or 1000 ml solution. That's 1 mole per liter in methanol. So multiply that by the molecular weight and then by the density. And the density, I've looked it up on Wikipedia, 1 mil delivers 0.792 grams of it. And I'm going to get 40.45. So let's go over to SoluBuddy. Go back to the website. Okay, it's pure neat liquid, and I'm going to do a volumetric transfer. Just check my numbers here. Solvent formula. This field, make a note of this. This field, solvent formula, should be changed to solvent name, because we don't need to know the formula for solvents. We never use their molecular weights to calculate concentrations of solutes, for example. We just refer to the solvents by name. So solvent formula can be changed to solvent name. And if somewhere in the program it takes that formula for the solvent and calculates the molecular weight, that's absolutely unnecessary. It's a waste of code. Solute formula. I'm going to add methanol, 32.04 grams per mole. Another comment on the fly here. You see, density of pure solute, which we're going to get to in a split second, has units, grams per mil. For completeness, parallel structure, solute molecular weight should have units, grams per mole. Anyway, back to the density, 0.792 grams per every milliliter. Total volume, forget that number. Oops, it was 40.45. Oh, wrong field. See, this is what the website is for. Keep students, help them organize this information and not get a little bit sloppy and lazy, like sometimes happen when people don't get enough sleep. Solution concentration, I'm going to make a 1 mole per liter solution, this 1000 ml. So I'll have to enter all this information. Okay, dense methanol with the given molecular weight and density. Okay, so the volume, 40.45. Next. Okay, well, it didn't complain at me, so I must have been right. You know, and this page, as we discussed on February 10th, can be reorganized a little bit with these graphics perhaps unnecessary, or the graphics can be made a little more teaching oriented. Anyway, and this can be reorganized. Maybe this is graphics put over here. And as we'll see in a bit, there's an alternate way to organize this page in terms of the relative alignments or locations of the names and the fields. I'll get to that in a second. But anyway, this part of the website apparently works because I've done an example done the numbers on a separate piece of paper and it worked out. Okay, so now let's go back to adding a solute that's in the form of a concentrated stock solution. Okay, and there's three options here. You know the molarity of that stock solution, and you want to do dilution, or you know the mass percent of the solute in the stock solution, and you want to do gravimetric transfer, mass percent solute in stock solution, and its density, and you want to transfer it volumetrically. So I think this is relatively well organized. Let's first do gravimetric. I'm going to jump back to my slideshow and overview these calculations associated with this operation. Okay. We're going to add a solute that's in the concentrated solution. So just for background, guys, many times we're making solutions starting with solutes that are not available pure. Like say we want to make a solution of hydrochloric acid. Well, there's no availability of like pure hydrochloric acid, but we have very concentrated solutions of hydrochloric acid. Let's calculate the mass of this concentrated HCl solution that we need to add. Okay, so we'll do the basic things first. Multiply, knowing this about the solution that we want to make. We're going to multiply its volume times the molarity in that solute, and that, by multiplying those two together, is going to give us what? Okay, and then that number of moles should have been your default response to that one. The number of moles is then going to be multiplied by the molecular weight. So this is HCl, so that's the molecular weight of HCl. Okay, that's the mass of HCl, and that's as far as the calculation would need to go if, for example, we were doing a solute that was like a pure solid, and all we needed was molecular weight. But the solute is not pure. It's in the form of this concentrated solution. And we know the mass percent. It's 36% by mass HCl. So there's different ways of putting that into the calculation. Just multiply that mass of HCl by this factor. 100 grams of solution is needed to deliver 36 grams of HCl. That's the same as 0.6, or I'm sorry, 1 over 0.36. Okay, so multiply those together and get 95.72 grams of the stock solution would be needed. So let's go back to the website. Okay, the mass percent of the solute in the stock solution want to transfer gravimetrically. Okay, water. Again, solvent formula can be just solvent name. Solute formula, HCl. Solution total volume, 1000. Okay, and it's going to be a 1 mole per liter solution. Percent mass of solute. Okay, that refers to the concentrated solution. Percent of mass to add. Okay, let's go out. What did we calculate? 95.72. You see one other thing that the website did. I guess you're seeing sort of the phases of development that we were in last time as we got this far. Basically, the website is, we have entered the formula for the solute, but the website is no longer asking for the molecular weight of the solute. So that's fine. It can be eliminated from those other pages as well. Okay, just to streamline this till we get it all working. I think there is some pedagogical value in asking them to make sure that they know the molecular weight. That can be an important part of the process because that's a place where students get messed up. So anyway, but at this point in the development of the program, we can add that in. Don't worry about that right now. We can add that in later. Okay, you can chop out places where they need to know the molecular weight. And like happens on this page, it just, after they give the formula, then it just calculates it. Okay, so calculate that. Well, it didn't complain, so it must have been, 95.72. This is a place where obviously I think my numbers are okay. I checked them a couple times. It's not that hard of a calculation. Anyway, I'm pretty confident in my numbers. So there is some bug in the program that I think might have been pointed out to you earlier. So let's go to the next one. I know the mass percent, and I want to transfer it mass percent of the solute in the stock solution and the density additionally, and I want to do the transfer volumetrically. Okay, so let's go back to my slideshow. Okay, walk through that. So again, the solute is HCl. We're going to stick with that. It's in the form of a concentrated solution, transferred by volume. Okay, so we want to know what volume of the stock solution we need to deliver the HCl that's going to be in the solution. Simple thing, simple operation. We're going to calculate the number of moles, foundational thing to know, number of moles of the solute in that solution by multiplying the volume by the molarity. Calculate the mass that's needed, or multiplying that number of moles by the molecular weight for HCl. Okay, then as we discussed in the last slide, the last operation we walked through, calculate. Now that we know the mass of the HCl that's needed, we need to know the mass of this concentrated solution that we need to, well, then we multiply it by 100 over 36. We're taking it one step further, calculating the volume. So I think the mass of the solution that needs to be added, which we've got by multiplying these first four things. So for this HCl, I'm going to show you where I got that. Okay, the density is every 1 mil of the solution weighs 1.18 grams. I'll show you from where I got that. Here's the website. There's the address there for someone that supplies values of this data. Now, maybe there's other websites that do this as well, but this one's pretty good, pretty straightforward. I think has all the information that we could possibly need, because the next one I'm going to do is doing it by dilution. So it also has the molarity. So it's got the molar mass of the solute, percent by mass, and the density. So for HCl solution, I'm pulling values from here. So there's this table on the website, publicly available. Hopefully it's relatively correct. We could check that out if we really decide to use it or promote that website. So anyway, by multiplying all those factors, including the density, finally, calculate the volume that's needed, 81.12. So let's go back to the website. Okay, formula HCl, total volume, solution concentration that we're preparing, 1 mole per liter. Percent of mass, it's a 36 mass percent. HCl solution is concentrated. Density, here, density of solute density. Density of, I think most people would know, if they really know what they're doing, would know what goes here. But we want to avoid error. So maybe this language could be changed to density of concentrated solution. And this should have units, shouldn't it? How many gram per every mil? With 1 mil over 1.8 grams. Wait, 1.18 grams per mil. Actually, without those units being specified, that's a little confusing. But I think, pretty sure that that's what it's asking. So we need to clarify things as we restructure this page. We're getting there. It's 81.12. 81.12. Again, just like on that last sort of operation, whatever, the last example, there's a bug, there's a breakdown in the formula. I think Dr. Wu discovered that as well and mentioned that, might have mentioned something to that effect at the start of the semester, that needs to be fixed. Okay, so we're going to do the next one. Okay, guys, actually, on second thought, I realized that this video is already getting a little bit long. I'll save that business about using dilution kind of processes to make solutions for a later video. Review that later. We will review that later. Okay, but one thing I would like to add in here at the end of this video, because we discussed this in our last conversation, okay, is what possible things can we do to integrate some teaching content into the website. And I looked at an example. Okay, here's a website that's available online. I don't know if you guys are familiar with physics education technology at the University of Colorado. I think they must have gotten some money, maybe from the National Science Foundation at some point in time, to support their education initiatives. Anyway, they've created a whole bunch of simulations for teaching, and they have one about acid-based solutions. And anyway, what I like about their splash page for this particular animation is that there's this very, very graphical choice at the beginning. Okay, do they need to go to the introduction, or just go straight to their solution, making their solutions? And anyway, I think I've hyperlinked this website to this, so we'll just go there. Please be patient, as my slightly old and slightly well-worn computer finally opens this website. Okay, so there's the introduction, and here's my solution. So making the solution, of course, then obviously they walk through something where they choose the nature of their solute or something like that. Views, molecules, what to include. But anyway, I like the aspect that the splash page is very graphical, and this is one way that we could, something that we could do to our website if we want to increase the teaching content. We could on the splash page just give them a very easy place to go if they want information, and also, as we discussed in our phone call most recently, we could put the little links, context sensitive help kind of things, directly into the website at points where people might want to learn a little bit more about the different things that they're handling in the program. Okay, so we'll go back. So this is, kind of, okay, we could make the website splash page kind of like this too. Two very graphical choices. Okay, want to learn about solutions. Let's do that. Maybe if they click that, then it could take them to a little page that has something like this. And so far, I can make a number. I've done YouTube videos that have already got a head start on this. Oh, I want to learn. I want to learn about molarity. What the heck is molarity? Okay, click that and go to the YouTube video once again.
Concentration units in chemistry. Why are
that sort of thing. Then maybe go back. Okay. Then if they're ready to do this, then this can take them to the home page, or take them to the page where they get all these choices. Okay. All right. Anyway, that's just one possibility for how we could make these website be a little more kind of student friendly. Okay, so that's the end of this presentation. Sorry it takes so long. Sometimes I hum and haw, but hope I'm getting some good information to you in terms of, for your project, what are the things you can do to take the program to the next step of development, and what sort of bugs you can clean up, and how we can make it cleaner and more user friendly. Okay, I will talk to you soon. All right.